We were challenged to build an assistive device that would help either a person or an animal, and we were given a budget of $40. We brainstormed different ways we could help people or animals with disabilities such as a tailless cat and deaf, blind, wheelchair-bound, the elderly, and those who are missing a limb. Ultimately, we decided to focus on those who are missing a limb and the elderly. We focused on an outside attachment and a harness for the user, but ran into safety issues. We then shifted our focus to improving the current handle and cars, but ran into the issue of lack of upper body strength. Finally, we decided on a removable arm that would rotate from 180 to 90 degrees. 4 prototypes, but had an issue with cutting perfect angles and drilling the holes. We decided to 3D print the joint to eliminate cutting at an angle. Our headrest didn't fit to an original headpiece, so we edited the spacing and reprinted. We also had an issue securing the 3D printed pin and decided to use a bamboo stick and a rubber stop to secure the pin.
Our group had many challenges that we had to overcome during this project in creative and innovative ways. One of our first challenges was communicating our design concepts, so our innovative solution was to use modeling clay to share our ideas visually. We also faced challenges with the complexity and safety concerns of our designs, so we did intensive visual brainstorming and sketches. We had challenges with our fabrication of our initial designs, and we had issues cutting the PVC pipe with precise angles due to the slickness of the surfaces. We also had trouble drilling our bolt at the correct angle. So our temporary solutions did not work, so we decided on our final solution, which was a 3D printed joint. The benefits of this including minimizing the cuts we had to make, ensuring proper rotation, and proper bolt angle. Another one of our challenges was displaying our device at FEDD, since displaying it in a vehicle was not realistic. So we created a mock seat to display the device on, which also ruled out another one of our challenges, making the device fit for all different headrest sizes. So the prototype is made to only fit the mock seat. Our final challenge that we faced was distributing force between the attachment piece and the headpiece. Our solution was to create a solid printed piece that was thermoformed using boiling water into the shape of an arch. The piece has an opening for the pipe, so the force is distributed equally along the arch.
So before we could actually start designing our own product, we had to look at previous designs and patents that had already been proposed. We first saw one that was a handle that could be placed inside of the lock and hoop created by the car door. Another one was a handle installed into the roof of the car that users could pull themselves out of the car with. And finally, there was a device that would be placed with the roof of the car and attached to the door of the car to help the person pull themselves out. Now, all of these had their own challenges and problems with them. So one was that they had to be removed after each use, especially for the handle that went into the car lock and the one that connected the roof to the door. The other one that connected the roof to the door could damage the car itself if used improperly, and the permanently installed one into the roof of the car would also damage the integrity of the roof. Also, they may not be reliable with every use, so the one that was installed into where the door hoop is had to be placed exactly right with each use and could then hurt the person if they were using it wrong. And the one that connected to the door would have to be installed from the outside in order to be completely secure for the person to enter or exit the vehicle. After we had researched previous designs, we also had to research the materials to use for our product. First, we looked at what materials to use for the prototype. We decided on PVC because of its easy cutting and also its low cost and availability in the resource room. Additionally, we 3D printed parts such as the plate that goes underneath the headrest and the joint for the actual device because we had access to the Engineering Village makerspace. For our final design, we chose that the pipes would be made out of carbon steel due to its higher stress strain capabilities when compared to other cheap metals like aluminum. But we decided that the joint would still be 3D printed, perhaps using nylon filament due to its great strength while keeping a relatively low cost. For our safety research, we decided to place our device completely alongside the side of the seat so that when airbags went off, we would be able to keep the device from impacting the user after the airbags went off. And we also decided to place cushioning on the pad on the part that goes beneath the headrest because it would allow for greater comfort for the user and prevent any injury during a crash that could be applied to the back of the user's neck.
For this project, there are a few things we could have done differently. Throughout the project, we ended up switching ideas quite a few times. If we had spent more time brainstorming and solidifying an idea we all agreed on, this could have been avoided. We could have spent more time researching our project before starting to work on it. This way, we could have created a better first prototype and not had to make several afterwards. We could have also better understood all the tools which were available to us in the makerspace. For our first two prototypes, we used an electric handsaw, which was difficult to control. But the third prototype, we used a manual handsaw, which gave us a much cleaner and more accurate cut. Next, we could have remeasured our angles and lengths before cutting, as this led to creating non-functional prototypes due to misalignments of the arm. Lastly, we did not realize that switching programs during 3D printing would change the scaling of our model. For future reference, we now know to check the dimensions of our piece when it is at the printer to ensure they are still the same as we designed them to be. For other teams working on FEDD projects, we offer this advice. Before beginning to work on anything for your project, do as much research as you possibly can. Consider every angle of your project. Consider safety, what has and hasn't worked in the past, and how feasible it is for the timeline you are given. Learn about all the tools and materials available to you for free in the makerspace and other areas on campus. Most of all, remember that this is a team effort. Keep everyone involved at all times and make sure to communicate with your team members. The FEDD competition is fun. Stay calm and friendly to everyone who comes by your project and be able to briefly and thoroughly explain what it is.
Our Flex ended up taking home second place out of assistive devices at competition. Fun fact, the judge actually broke our prototype while they were judging us, so we were a little nervous.